In this video, I'll be working on lab number 8 from the Cisco CCNA lab guide, which is a free download from Flackbox.com. The name of this lab is Dynamic Routing Protocols. It says in this lab you will examine features which are common to all interior gateway protocols. Basic configuration for various IGPs is included, but is not the focus of this lab. Configuration of IGPs will be covered later. Okay, so we have our topology over here, packet tracers open. Let's get started with routing protocol updates. It says enter the commands below on each router to provision a basic RIP version 1 configuration and enable RIP on every interface. So there are 3 commands. It wants us to do it on every router, so I'm going to open up Notepad and cut and paste to save some time in the video. So the commands it wants us to enter are router, RIP, and then network. It's going to be 10.0.0.0 and no auto summary. And since we're just, let's see, okay, so should be able to just cut and paste this, save a little bit of time. So we're going to do it on each router. Starting with router 1, go to command line, hit enter, enable comp T, and we should be able to just paste this in, and that one's done. That's router 1. Let's go to router 2 and enter, and let's add a little something to the beginning here. Let's add enable and comp T to save a couple of steps on the rest of them. So copy that, and this is router 2. So I'm going to paste that. That's done. And you can create configuration templates for your devices and cut and paste them just like I'm doing. And it works on packet tracer and it works on real equipment too. So that's router 2. Let's go to router 3. Command line, enter, we're going to paste, enter, 3 is done, go to 4, command line, enter, and paste, enter, and 5, router number 5, and we'll paste that in. And really simply, it's just that you're enabling RIP and you're designating the network, the 10 network, which would be all of these, but not this, because this is going out to the internet, so you wouldn't want to add it to that. All right, it says number 2, debug the routing protocol updates on R1 with the debug Iprop command. So let's get into our router 1, and we'll drop down to global configuration mode. And we're going to, actually we need to drop down to privilege exec mode, I think, for debug. Let's see. Yeah, debug Iprop. Okay, and RIP protocol debugging is on, as you can see there, and it's starting to send updates. And it says observe the updates being sent and received. What kind of traffic is used? You can see here it's broadcast traffic, 255, 255, 255, 255. So RIP is using broadcast traffic for that. Next step, enter the commands below to enable RIP version 2 on every router. So let's go back to our notepad since we're going to do it on every route for every router. I'm going to minimize this a little bit. And let's do router RIP version 2. And we're going to cut and paste that into each of the routers. So that, starting with router 1. Let's go ahead and click here, and we're going to go to enable comp T, and then we're going to paste that in on each router. So there's that one, and then router 2. Let's add the exit command to the beginning of this. We'll drop down to global configuration mode as I cut and paste them. All right, minimize that. So we're on router 2. We're going to paste that. Done. And see, it just entered in exit and then the commands we were doing. Router 3, same thing. Enter. Router 4, paste, enter, and router 5. Paste and enter. And that command, that's number 3 is done. What kind of traffic is used for the updates now? So we updated to version 2 of RIP. So RIP 2 uses multicast. So here's a RIP 2 v2 update on fast Ethernet 00. And if we look right here, you'll see, you'll see it was sent via 224.0.0.9. You see it right there. And that is the multicast for RIP version 2. All right, now it says turn off all debugging on R1. So we'll go back into R1 and we need to get back to privilege exec mode, and we do the undebug command, undebug all, and that just turns it off. All possible debugging has been turned off. All right, it says check that RIP routes have been added to R1, and it has a route to every subnet in the lab. So we need to make sure it has a route to all of these. So we're going to go check that RIP routes have been added. To do that, you do the show IP route command, and we'll open this up a little bit, make it easier to see. I'm going to hit the space bar, and I need to open this up a little more. There we go. All right, so we need to make sure there are routes everywhere. So we're at router 1. It's going to know about all of these over here, all of these, because it's directly connected. So we need to make sure that RIP added these. All right, so there's 10.0.0.0, which is here. We got that one is directly connected. Let's go down here. 10.1.0.0 added, 10.1.1.0 added, 10.1.2.0, and 10.1.3.0. So all of these that we expected to be added have been added. So that's done. Why are there 2 routes to the 10.1.1.0/24 network in the routing table? Let's look. Didn't mean to do that, but we'll just open it up a little bit. And it says, why are there 2 routes to 10.1.1.0, which is right here. And so you have a route going via 10.0.0.2. So here's 10.0.0.2, so one route going this way. And then you have a route via 10.0.3.2, which is, this is the 10.0.3 network. So down here, 10.0.3.2, you have one going this way. And this is the administrative distance, and this is the metric. So RIP has an administrative distance of 120. And the way that the routers work is you can add multiple protocols. You can have like RIP and open shortest path first, etc. And then what the router does is it looks at the administrative distance first. So, and then whichever protocol has the lowest administrative distance, that's the protocol it will use. Then the router will look at the metric, and the metric is different for the various protocols. But then based on the network, it'll choose which paths to use. And in this case, there are 2 paths to 10.1.1.0 that are both, RIP uses hop count. So both are 2 hops away. So you can see here 10.0.0.2, so 1.2 to get to this network, and then via 10.0.3.2, 1.2 to get to the network. So they're both the same, so it'll put both in the routing table, and it'll load balance between the 2. So that's the answer to that, I believe. Now we're going to compare routing protocols. It says view the RIP database on R1. So to do that, the command is show IP RIP and then database, and hit enter. And what does it want us to look for? View the RIP database. Okay, so basically there's the RIP database, and it doesn't show a whole lot. These are the directly connected ones, and then these are the networks that are over here that aren't directly connected. All right, enter the commands below on each router to provision a basic open shortest path first configuration and enable Ospf on every device. All right, let's open up Notepad again, since we're going to be putting this on everyone. We're going to enter router, open shortest path first, 1, and then the network, which is the 10 network, 10.0.0.0, and you're going to do a wildcard of 0.255.255.255. So basically it's just saying, hey, everything in the 10 network we're going to look at. And then you have to designate an area, which is area 0. All right, that looks right, 10.0.0. And let's copy and paste this into all the routers. So we'll minimize that, and we'll go into R1, and we're going to have to go into Comp T, and we're going to paste, and enter. That's done. Router 1's done. Router 2. So let's go back and enter an exit command at the beginning here to drop us down into global configuration mode for the remaining routers. So close that. We're at router 2. We're going to paste, enter. Router 3, paste. Router 4, paste it in there. Router 5, and that should be all we have to do for that step. So enter the commands below, did that. So we've provisioned a basic open shortest path first configuration. Number 10, give Ospf time to converge. So our RIP tables, our RIP routes included in the routing table on R1 now. Why or why not? Well, they shouldn't be, because open shortest path has a lower administrative distance. And if we do, I think we did a show IP route up here. Yeah, so we did a show IP route, and at the time RIP was running, and RIP has an AD value or administrative distance value of 120. So anything that's less than 120, the router's going to choose that protocol, and the routes that are then determined by the metric of that protocol. So let's do a do show IP route. Okay, and we'll move this over a little bit. And we should see whether or not the RIP entries are there. So RIP is designated by an R in the codes up here, and O is open shortest path first. And if we look down here, all the RIP entries are gone, and they're all replaced by open shortest path first. Okay, so that answered that. Number 11, why are there now only one route to the 10.1.1.0 network? Well, previously RIP had 2 routes because it had 1-2 hops to the 10.1.1.0 network this direction, and 1-2 hops to it via this direction. But open shortest path first doesn't just rely on hops, it's taking the speed of the interfaces into the connections into play. So let's look at the results of show IP route again, and they're there, and it's saying why is there only one route to 10.1.1.0, and that's right here, 10.1.1.0. So, and you can see the administrative distance for open shortest path first is 110. RIP was 120, therefore open shortest path first was chosen because it's a lower number. And then this is the open shortest path first metric determining the best route. So it determined that this via 10.0.3.2, which is this one, is the best route to get to 10.1.1.0. And I'm thinking that has to do with the speed, so we'll find out though. Disable, and so number 12, yeah. So disable interface fast Ethernet 00. You know, it's kind of weird actually. If I look at that again, why did it take that route? So 10, it was asking us about why is there only one route to the 10.1.1.0. Here's 10.1.1.0 via 10.0.3.2. It took this one, I guess, because a combination of things. So let's look at the speed. Let me rerun that command. Okay, it updated it. There we go. So now 10.1.1.0 is via 10.0.0.2. Okay, and because I've done this lab before, I knew that there's a speed issue that should have updated. So what you can do is, if you see that and you're uncertain, you would think, okay, if you thought, well, if everything's configured by default and they're all fast Ethernet interfaces, why would it choose one route over the other? And you can find that answer by going into, so for example, we'll look at router 2 and we'll do a show interfaces command. So do show interfaces, and when you pull that up, you will see that the bandwidth is 1, 2, 3, so 100,000 kilobits, and 100,000 kilobits divided by, well, 1,000 for a kilobit is 100. So the speed of the interface going this direction is 100. And then if we do the same thing on router 5, and we do a do show interfaces, and we look at the bandwidth there, you will see right here, bandwidth. So that's 10,000 kilobits. So 10,000 but divided by 1,000 is 10. So this router is configured to have 10 megabit per second speed, and these were either default or configured to have, well, that is the default of fast Ethernet, I believe, 100 megabits per second. So this is faster. These are faster connections than down here. Therefore, open shortest path first hook this direction. All right, so disable interface fast Ethernet 00 on R2. Let's do that. Hit Q in packet tracer. We're going to hit exit to get down global configuration mode, interface, fast Ethernet, and it's 00 we're supposed to get rid of. And we're going to do a shut. We're going to shut it down because it's saying disable it. So we should look at it, and the topology, you can see it's red there. You could also verify this on real equipment. Obviously, you wouldn't see that little red dot by doing a do show, if I could type IP interface brief, and you will see that interface 00 is administratively down. So we issued the shut command, the shutdown command, and brought it down. So what do you expect to happen to R1's routing tables? Well, they should be updated because now R1 can't route this way because this is closed. So everything should be updated to be going through the 10.0.32 next hop. So let's do that, and do show IP route is the command, and we should see, other than the directly connected ones, they should change, and then here they are. So 10.1.0.0, 10.1.1.0, 10.1.2, and 0 and 10.1.3.0 are all going via 10.0.3.2, and you'll see it right there. So we closed this connection, we shut this down, unable to route this way, so router 1 updated its routing tables with this path here. And we did verify the expected changes. So now, aside from the next hop address, what else has changed on the routing table? All right, so if we look at that again, and do show IP route, will show you the routing table. You'll notice that it is, I guess what we're looking for is the fact that it's open shortest path first, and this is the administrative distance. The next hop is changed, and then the metric for administrative distance. So if we go back up here, that looks, I guess that's about it. I guess just the next hop changed. Let's see again. Let's look at that again. These have an administrative distance of 110 with a metric of 20 through 22. Okay, this is different too. These have an administrative distance of 110 for open shortest path, but the metric is much lower up here. So now that this is closed, these better routes, considered better because they're lower numbers, have been replaced with these higher metric routes because that's all that's available. So that changed too. View the open shortest path first database on R1 with the show IP open shortest path first database command. So let's do show IP open shortest path first database. And what is the difference between it and the RIP database? We can go back up and look at the RIP database, which should be here. So we don't have a whole lot of information with RIP. RIP is going to work by sharing with directly connected neighbors, and then whatever those neighbors share back to that directly connected interface. Whereas open shortest path first is going to give you an idea of the whole network. So if we do the up arrow again, do show IP open shortest path first database, you'll see information about, for example, here's 10.1.1.1, it knows about this link. 10.1.3.1, it knows about this one, and etc. So that's the difference between those. All right, so let's move on to routing protocol metrics and administrative distance. Excuse me. Enter the command below to remove Ospf on every router. Okay, so let's pull up Notepad again so we can cut and paste thing. So no router, open shortest path first 1, and shift home to copy that. And no router, open shortest path first 1. So we're going to remove it on every router. So let's go down here and we're going to hit N, we're going to do Alt T, and we're going to hit paste and hit enter. Router 1 is done, router 2. All right, let's enter the exit command so we can drop down a level at each of the other routers. We'll copy and paste this. All right, we're on router 2 now. There we go, that's done. We'll move on to router 3, hit enter. Paste, and that brings us down there. That's 3 is done. 4, paste, enter, and to number 5, and that should complete that step for us. So we'll hit paste and we'll hit enter. All right, so that step is done. Enter the command below. We've removed Ospf on every router. So 17, will R1 still have connectivity to R4? We just removed open shortest path, and it's saying will it still have connectivity to R4? The answer is yes, because RIP is still running. We didn't remove RIP. So let's look at the do show, get this out of the way, show IP route, and we will see that it's R4 is over here, and we can see that we have connectivity over there to the 10.1.0.0, 10.1 networks over here via 10.0.3.2, right, which is right here. So yes, even though we removed open shortest path first, you can see RIP replaced it because that was still there. We never removed it. We just removed open shortest path first. RIP previously wasn't used because it has an administrative distance of 120, which is higher than Ospf. So that answers that question. And we're on to number 18. What is the metric to the 10.1.1.0 network on R1? So the metric to the 10.1.1.0, let me highlight this, is right here. So the administrative distance is 120. That's the first number. And then the metric is 2. And for RIP, metric simply means hop count. All right, we'll close that. 19, why is there only one route to R1 on the 10.1.1.0 network? 10.1.1.0 is over here. Well, the reason there's only one route is because this route is closed. We took this interface down. We shut it down. All right, let's move on to another 20. Make the required change so that there are 2 routes to the 10.1.1.0 network in the routing table in R1. Well, it's using RIP, and previously RIP had 2 routes because they were equal. 1-2 hops, 1-2 hops to get to this network. So all we have to do is bring this interface back up. And then so we'll go to interface, fast Ethernet 00, and we'll do the no shut command. No shut. There we go. Move that out of the way so you can see that. And we should see the interfaces back up. All right, so we made the required change, And now it's saying, enter the commands below on each router to provision a basic EIGRP configuration and enable it on every interface. Okay, let's open up Notepad again, and let's enter router EIGRP 100, and then no auto summary. And then the network is going to be the 10 network again, so 10.0.0.0. And the wildcard of 0.255.255.255. So you're just basically, it's saying, hey, everything in this network we're going to work with. So we have router EIGRP 100, no auto summary, and we have the network and the wildcard. So we will copy and paste this on enter the commands below on each router. So we're going to do that for each router. Start with router 1. And this, we're in global configuration mode, which is right. So let's go to router 2. And we need to exit. So let's add that to our template. Save us a step. And we will copy and paste that. Close that. Paste it here. All right. Oh, invalid. Entry, I made a mistake somewhere. I'm going to pull this over here. It may be that I was in the wrong spot. Let's see. So let's do conf t, get in global configuration mode, and now let's just try copying from here down. That should work. Let's see. And then hit enter. Yeah, okay, good. So that worked. It's up, so that worked. So that was router 2 on to router 3. We're in the right place for global config. Hit enter. Router 4. Paste. Router 5. Paste. Enter. We're done with that command, with that step. All right, so enter the commands below. We did this. Now it says, what changes do you expect to see in the routing tables? Why? Well, EIGRP should be showing up now. So do show IP route is the command you need to look at the routing tables. And let's see, we had, so under the codes, D stands for EIGRP, and there you go. Let me hit the space bar down here. So you're seeing D, which is EIGRP right here. And the reason that it now is appearing in the routing table instead of the other protocols is it only has an administrative distance of 90. So again, the lower the administrative distance, that's the first thing the router is going to look at. The protocol with the lowest administrative distance is going to get chosen first. Okay, so that answers that. Verify the changes to the routing table. We just did. We looked at that. What is the metric to the 10.1.1.0 network on R1? So the metric to open this up a little bit, to the 10.1.1.0 network, the metric is right here, 33,280. Again, administrative distance followed by the metric. The lower of each of those, the more likely it is to get into the routing table. All right, why is there only one route to the 10.1.1.0 network on R1? All right, let's look at that again. 10.1.1.0 has only one route. Okay, it's the same as before. We talked about how, well, EIGRP also takes bandwidth into consideration. So this is a slower route as far as the configuration being down here was 10 megabits per second, and these are configured for 100 megabits per second. So EIGRP is going to favor the faster route up here. All right, so that's why there's only one route, because this is not as fast a route to EIGRP as this is. All right, so let's go to 26. Disable Rip and EIGRP on R5 with the commands below. All right, we don't need to use Notepad because it's just one router that we're going to do this to. Hit enter. Exit down to global configuration mode, and we're going to enter these commands: no to router rip, no router rip, and no router EIGRP 100. Okay, so number 26 is complete. It says configure the networks so that there's still connectivity between all subnets if the link between R1 and R2 goes down. Accomplish this with 6 commands. Do not enable EIGRP on R5, but note that the routing protocol is expected to be enabled there in the future. So So what we have to do is we have to set up what are called floating static routes as backups to the routes that are already there. And if you look at the routes right now, I'll open this up a little bit, you can see that the EIGRP has an administrative distance of 90. And the way you set up floating static routes as backups is you manually increase the administrative distance. And the way you would do that is, well, the other thing is it's saying do this in 6 commands. Well, the only way you could do it in 6 commands, because there's more than 6 networks, is by using summary routes. So we'll open this back up, and we're going to start at router number 1, and we're going to drop down to global configuration mode. And to set up a summary route, so basically what we're going to do is we're at router 1, close this, and we want to tell it about all the 10.1 networks. So 10.1.0, 10.1.1, 10.1.2, and 10.1.3. We want to tell it about all of those in one command. And the way you do that is you use the subnet mask. So you tell the router to only look at the first 2. So you're going to use a /16 subnet so that it knows to get to any 10.1 network, whether it's 10.1.0, 1, 2, or 3, it's going to take this as the next hop, 10.0.0.2. All right, so let's go ahead and configure that. And to do that, the command for that is iproute. We want to go to the 10.1 networks, which are these. We want to enter that in. So we're going to do, let me leave that there, 10.1.0.0. And then you have to give it a subnet mask of 255.255.0.0 because you're giving it a /16 because you're telling it, hey, only pay attention to anything that's covered by these first 2 octets. So in other words, any 10.1 network, go this direction. And the direction we want it to take, we're going to tell it to take, is because it said if this connection went down, so we have to tell it it's going to go through the 10.0.3.2 route as the next hop. So we'll do 10.0.3.2. And again, back to the administrative distance, we don't, one of the things about static routes is they have a lower administrative distance number than OSPF or EIGRP, RIP, you have it. I think it's like a 2 or something. I don't remember exactly, but it's really low. So it'll always take precedence, and we don't want this to take precedence. We only want this to kick in as a backup if this route goes down, okay, if this connection goes down. And so you manually change the administrative distance to be just a bit higher than what EIGRP is, so we'll set it to 95. Okay, so we got that. That's done on router 1. Let's go to, I'm going to go ahead and see if I can't copy and paste this and then just make the changes. So now we're going to go to router 2. Router 2, we're going to do the same thing. We're going to tell it about the, but this time with router 2, because it's directly connected to the 10.1 right over here, we need to tell it about the 10.0 networks. 10.0 networks, 10.00, 10.01, 10.02, and 10.03. All right, to do that, let's drop down a level, and I'm gonna paste that here. So IP route, and instead of the 10.1, let me open this up a little bit. Instead of the 10.1 networks, we want to tell router 2 about the 10.0 networks. So we'll scroll over here, make that a 0. So 10.0.0. Again, the subnet will stay the same of 255.255 because we're telling it, hey, anything that's a 10.0 network, go this way. The next hop will change though, because that's going to be going back this way from router 2. No, this connection will be down, so it's got to go this way. So it's going to be 10.1.0.1 for the next hop, and we'll change that right here. Well, I don't know why I did that. I'm just going to do Control U to erase the, Control U should erase the whole line. Well, I guess not. Control E should get us to the end, and then I think Control U will erase the line. There we go. Let me just type it in again. So for router 2, it's going to be IP route to the 10.0 networks, 10.0.0.0, 255.255.0.0 as the subnet. The next hop for router 2 would be this direction. So it's going to be 10.101, 10.101, so 10.1.0.1, and we need to set the administrative distance a little higher than what it currently is with EIGRP. And if you remember, it was, well, it's not shown on there. Oh, I was looking at router 1, that's why. It was 90, so we need to set it to 95 manually. All right, R2 is done. Let's go to router 3, hit enter. Exit down to global configuration mode. So for our router 3, we need to tell it about the 10.0 networks, 10.00, 10.01, 2, and 3. So we need to tell router 3 how to get this way if this connection, how to get to these if this connection goes down. And we're going to do that. Let's open this up a little bit. Okay, so for router 3, we're going to tell it create an IP route to the 10.0.0.0 networks, 255.255.0.0 for the subnet. For router 3, it's going to go through the 10.1.1.1 next hop. So 10.1.1.1, and we need to up the administrative distance to 95 manually, so it acts as a backup and doesn't take precedence over the current routes. Okay, so that's router 3. We'll go to router 4. We're going to open this up a little bit. Router 4 also needs to be told about the 10.0 networks. So we'll hit that, we'll hit exit, and we're going to do IP route, and we're going to do 10.0.0.0, 255.255.0.0. This is router 4, so its next hop is going to be 10.132, which is this one on the 10.130 network. So the next hop to get over here, if this connection goes down, will be this way. So the next hop will be 10.1.3.2, right? Yeah. So we'll enter that in, 10.1.3.2, and we need to up the administrative distance to 95 manually. And then for router 5, if this went down, currently router 5 can get to these networks or these networks, the 10.0 networks or the 10.1 networks, and it's got 2 routes, so we're going to have to configure 2 different routes for it. It's for both the 10.0 network and the 10.1 network if this connection goes down. So if this connection goes down and we need it to get to the 10.0 networks, which are over here, let's for router 5, we're going to do IP route, and we're going to do the 10.0 networks and 255 as the subnet. And then we'll want it to go, if this is down, the only way to get there will be this way. So 10.0.3.1. All right, so that's going to be 10.0.3.1, and we're going to give it an administrative distance of 95. Okay, that's the first set of networks using a summary route. We also need to tell router 5 that if this connection goes down, it can't go this way to get to the 10.1 networks. It has to go this way. So we'll do the up arrow, and we're going to change it to the 10.1 networks, and then Control E to end, because the subnet mask will stay the same. But in this case, to get over to the 10.1 networks, we're going to have to change it to the next hop to this interface, which is 10.1.3.1, 10.1.3.1. So let's change that to 10.1.3.1 and give it administrative distance of 95 so it acts as a backup. And I believe that's everything. So it said configure the network so there's still connectivity if the link between R1 and 2 go down. Accomplish this with 6 commands. Well, we did, because we did 1 command here, 2, 3, 4, 5. Oh, 1 here, 2, 3, 4, 5, 6, because we had to do 2 here. Do not enable EIGRP on R5, but note that the routing protocol is expected to be enabled there in the future. That's why we included, even though EIGRP is not there now, let's look at it right quick. Do show IP route. Right now it's only got, it doesn't have EIGRP, it's just got the local and the connected routes and the static routes. But if we're going to add EIGRP, we don't want the static route, the floating static route that we set up to take precedence. We want EIGRP to. That's why we included that change to the administrative value, the administrative distance on that one too. All right, so we're moving on to number 28. What changes do you expect to see to the routing table on R1? So let's look at it. The routing table on R1, and we're going to do show IP route. So hit the space bar. Let's open this up a little bit. All right, what changes do you expect to see in the routing table? Well, I guess I should have tried to answer that before looking at it, but anyway. So on router 1, we're going to have, we have a summary route here. We have D, which is EIGRP. We have all those routes listed. And we created a summary route on R1. Remember, we created a summary route to these networks via this direction, 10032, and we see that there. But it's got an administrative value of 95, or administrative distance of 95, which is higher. So the router is going to choose this path by default. It'll only use this path if this path were to go down. So I think that answers that question. Verify the changes. We did that. We just looked at the routing table. It says verify the traffic from PC1 to PC3. So PC1 to PC3 still goes via R2. So if we're going to see how the traffic goes, we'll have to do a trace route. So let's go to desktop, command prompt, and we're going to do trace route. In Windows, it's trace RT. And we're going to PC3, which is 10.1 to 10, 10.1.2.10. And let's see the route it takes. So it started here at PC1. It went to 10.0.1.1, which is this interface, 10.0.1.1, which is this one. Then it went to 10.0.0.2, which is this way, and then 10.101, which is here, and then 10.111, which is this one, and then it went up. So the answer to that is, did it go via R2? Yes, it did. All right, so we're at 31, shutdown interface, fast Ethernet 00 on R2. Okay, we'll do that. We'll do interface, fast Ethernet, and I'm just tabbing to complete as I partially type to speed things up. 00, and we're going to do the issue the shut command. You can type shut or shutdown, either way will work. And if we look at packet tracer, we'll see that it's down. What changes do you expect to see on R1's routing tables? Well, these routes will be gone that were previously there. The only thing that's going to be left are these routes. So let's do that. Let's do a do show IP route, and we'll open this up. And since this connection is down, you have a summary route here, which kicked in. So this summary route to 10.0.3.2 kicked in because this is no longer an option. So those routes are gone. So the backup floating static route that we created as a backup worked. All right, so now 33, we're going to verify the changes to the routing table in R1. We just did that. Verify connectivity between PC1 and PC3. Well, connectivity is a simple ping. So ping 10.1.2.10, and we have connectivity, so that's good. And verify the traffic goes via R5. So once to verify it's going to, well, it's going to, there's no way it can go here, but we'll do it anyway. So let's pull that up, and we'll do a trace route, and we're going to do trace route to 10.1.2.10, which is PC3 over here, and we should see it going via the 10.0.3.2 next hop, and there it is, 10.0.3.2. So it did do that. All right, bring the interface fast Ethernet 00 and R2 back up. All right, we'll go back in there, and we can just issue the no shut command for no shutdown. And EIGRP kick back in, creating an adjacency between these two. Number 37, enter the commands below on R5 to provision a basic EIGRP configuration and enable it on every interface. So previously we hadn't set up EIGRP. We set up the floating static routes as backups, but EIGRP was not on there. So we're at router 5, and we're going to do router, and I'm tabbing to complete EIGRP 100, and then the next command is no auto summary, and the final command, we're going to enter the network, the 10 network, 10.0.0.0, with a wildcard of 0.255.255.255, because we want everything in the 10 network. All right, so that should be done. Close that. Now we're going to look at loopback interfaces. So loopback interfaces are not physical interfaces. They are just logical interfaces that you can configure so that if you lose a route, say you had only had this IP address for this router. I think this is where loopbacks come in. If you only had this, you only knew this interface, the 10.0.0.1 interface on R1, but you also knew the loopback address. If you only had this interface as the only IP address to get to on R1, you wouldn't be able to if this connection went down. But if this connection goes down and you've configured a loopback address on R1, you'll be able to get there this way. So configure a loopback interface 0 on each router, assign the IP address 192.168.0.x/32, where X is the router number. So for example, router 12345. That's how we'll have to walk through it. So the commands for that, and let's open up Notepad again. So you'll type in interface loopback, and we want to call it 0. That'll be the first command, and then the second command is going to be the IP address. So we're going to give it the IP address of 192.168.0.whatever for the router number /32. So to do that, we're going to do 192.168.0.1 for router 1, and we're going to give it a subnet mask of 32, which is all 255. So 255, 255, 255, 255. So we have the IP address 192.168.1 for router 1 with a /32. So we'll copy and paste this and just change this value right here. So let's copy that. Let's go to router 1, and we will paste. Oh, I made a mistake. So I did lookback, not loopback. And quickly change that, copy that, cancel, minimize, don't close. So let's paste that. So we have our commands of interface loopback 0, IP address, change the state to up. All right. I don't need that line. Control U, get rid of that. Okay, so we got it there. There's interface loopback 0. We gave it the IP address 192.168.0.1 because it's router 1 with a /32 subnet. All right, so let's copy that, and we will just change that to a 2 for router 2. We'll copy that, go to router 2, which is here, hit enter, exit down to global configuration mode. Let's hit paste. All right, we got it. That's done. We're going to go to router 3. We're going to paste that in. That's done. Okay, router 4. Hit enter. Again, paste. IP address. Oh, I messed up. Hold on. I got ahead of myself. So router 1 we got is 192.168.0.1. Router 2 I set as 192.168.0.2. Router 3, I made the mistake of making it 0.2, so I need to I need to go here, and that should have been 3. So IP address, I'm going to just enter Control A to jump to the beginning of the line, and I'm going to put no in front of it, issue the no command. So we'll pull that out because that wasn't correct. And now we want to up arrow, and we'll hit Control A to go to the beginning. We'll get rid of the no. and we'll go Control E to go to the end, and we need to change this number to a 3 because it's router 3. So we do that, and let me open this up a little so it's easier to see that. Okay, that should fix that. Let's make sure do show IP interface brief. And there's loopback 192.168.0.3 for router 3, which is router 3. And it's okay, good, that worked. So now we need to cut and paste this. We need to change that to a 4 for router 4. And we will copy and paste that. Go here to router 4. And we're going to hit, we also did the same mistake here. I put the .2 instead of .4, so I need to do the up arrow. Control A to jump to the beginning of the line here. Just type in no. That'll take care of that. Up arrow again, Control A to the jump to the beginning. Remove the no. All right, and then Control E to go to the end here. And we're going to scroll back and let me open this up a bit. Change that 2 to a 4 because everything else will stay the same. Okay, hit enter. That should take care of that. And then we go to router 5 and we're going to exit down to global configuration mode. We're going to paste, and I did it again. Keep doing that. I keep forgetting. So up arrow, Control A to go to the beginning, enter no. That takes care of that line. Up arrow, Control A to go to the beginning, get rid of the no. Just issue the command IP address. We're going to open this up, and we're going to hit Control E to go to the end, and I need to change this 4 to a 5 because we are on router 5. So that should take care of that. I hope I didn't mess anything else up. All right, so configure the loopback interface. We did that. So now it's asking, is there connectivity to the loopback interfaces from the PCs? Why or why not? Well, let's find out. So we'll do PC1, and we'll hit command prompt, and we're going to do we're going to ping, and the interface for router 1 was 192.168.0.1, and it says destination host unreachable 192.168.0.1. that was on router 1. Let me make sure I have that right before I make any comments on this. Do show IP interface brief, and let's see if the loopback is there. It is. Oh, I messed something up. So it's unassigned. I didn't assign loopback when I'm R1. Let's try it again. So the command for that is going to be the interface loopback is already there, so we just need to give it an IP address. So I got to hit exit to drop down. And no, I need it to actually be in there. So interface loopback, and we call it 0. And then I need to give on R1 the IP address of, and it was going to be 192.168.0.1 because it's router number 1. And close this, right click, and open that up, and then give it a subnet mask of /32, so 255.255.255.255, and enter. And now when we do show IP interface brief, we should see it configured properly. There it is. Loopback on router 1 is 192.168.0.1, so that's correct. Let's go back to the PC, pull up the command prompt, and we're gonna ping again. Okay, so we do have connectivity between router 1, the PC1 and router 1. So now let's try connectivity from PC1 to, say, router 2 or router 4. All right, so pull up the command prompt, up arrow to bring back the ping, and we're going to do, instead of router 1, we're going to do router 4. So we just changed that. And it's telling us that the destination host is unreachable. So one thing that to notice about the IP addresses that we set for loopback, that's a 192 address. So that's RFC 1918, which is unroutable address spaces. That's what you use in your internal network. It's 10 dot anything, 172.16 through 31 anything, and then 192.168 anything. You use those internally on your internal side of your network, and then that would translate it, network address translation would translate it to your internet facing IPs. But the reason why this PC was able to ping this interface is, even though it's not actually being routed, it's right there. I don't think you would consider that being routed if it's an interface on the router. It's not actually going anywhere. Whereas a 192.168 is non-routable, so to get from here to here, these routers aren't going to even pay any attention to that. They're going to ignore that because to them that's non-routable address space. And again, I think it's RFC 1918 is what covers that. So did we answer the question? Is there connectivity to the loopback interfaces from the PCs? Well, yes and no. It's going to depend on a directly connected network. We'll know about it because it's right there on that PC, but they're not going to show up in the routing tables over here because we just haven't done that. So the answer is yes and no. So 40, enter the commands below on each router to include the loopback interfaces on EIGRP. So now we're going to actually tell the routers how to get to those networks. So enter the commands below on each router. So I'm going to pull up my notepad again because we're going to reuse these. And the commands are router EIGRP 100, and the network will be 192.168.0.0 with a reverse mask of, or a wildcard, I don't remember what that's called, 0.0.0.255. So anything in this network, and then the only thing that's going to be host that they're going to be even worrying about is this, but so anything. So router EIGRP 100, network 192.168.0.0 with a wildcard of 0.0.0.255, and it's saying add that to every router, each router. So yep, let's do that. We should be able to just copy and paste, and we will exit down a level, exit, and we'll paste it to router 1. Done. Now let's go to router 2, exit down a level, paste. Okay, that one's done. Router 3, I should have added exit to the template, but oh well. Now we're at router 4, and exit, and we will paste, and finally we'll do it with router 5, and exit, and paste, and enter. So that's done. Okay, so we entered the commands to include the loopback interfaces in EIGRP. So now all these routers know about the loopback of 192.168. So 41 says verify the loopback interfaces are in the routing table in R1. So that'll be easy enough. We'll just open that up. We're going to spread that out a little bit. And we're going to do show IP route, which is the routing table. I hit the tab bar to page down. And then if you look here, you have 192.168.0.1, etc. and via EIGRP, which is D. So 192.168, 1, 2, 3, 4, and 5 for each of the 5 routers. So it'll be able to get to them now. So 42 is verify connectivity from PC1 to the loopback interface on R5. So let's go to PC1, and we're going to open the command prompt, and we're going to ping 192.168.0.5 because it's router 5, and we have a response. So we have connectivity there. All right, the next one is adjacencies and passive interfaces. It says enter the command below to verify that router 1 has established EIGRP adjacencies with R2 and R5. So here's router 1, 2, and 5. So we want to enter this command. It's kind of small. So we're going to go to router 1, and I'm going to drop down to privilege exec mode. And you probably can't even see that, but the command is show IP EIGRP neighbors. Show IP EIGRP neighbors, so you can see. All right, and then this is router 1, and then it's showing the address of 10.0.0.2, so 10.0.0.2, so it knows about R2, and 10.0.3.2, which is down here on the 10.0.3 network, and it's .2, so that's done. All right, so R1 has established adjacent EIGRP adjacencies with R2 and R5. The next step is verify the traffic from R5 here to the directly connected interfaces on R1, which would be these, goes via the fast Ethernet 01 interface. Okay, so verify traffic. So if we want to see where it's the route it's taking, we need to do a trace route. So just hit end, and we'll do trace route, and in Cisco it's the actual full thing, trace route, as opposed to Windows, which is just trace RT. And verify the traffic from R5 to the directly connected interfaces on R1. So we will, this is, for example, 10.0.2.1 would be a directly connected interface. So 10.0.2.1, let's see, goes via the fast Ethernet 01 interface. And if it went out here, it should have gone to 10.0.3.1, which it did. So it did. It went out this way, not that way. And that's what we wanted to confirm. Okay, that's done. It says enter the commands below to configure the loopback interface and the link to R5 as passive interfaces on R1. So a passive interface is where it's not going to share network information with each other. The link is still there. It's still a good link. You can still have traffic go over it, but these two routers on a passive interface aren't going to share network information. So R1 isn't going to tell R5 about the networks behind it. So enter the commands below to configure the enter the commands below to configure the loopback interface, and the link to R5 is passive. Okay, so enter the commands below to configure the loopback interface, and the link to R5 is as passive on R1. So we need to do this on R1. And we'll open this up a little bit. And the command, we got to go into first global configuration mode, so comp T, and then it's showing here that we should be in an interface configuration mode. So, and the link to R5. So the link to R5 is 10.0.3.1. So we're going to go, which is fast Ethernet 1.1. All right, so we have to type interface fast Ethernet, and I do believe I said 1.1. Yes, 1.1. All right, and we'll start by typing the commands they have here. Router. See, I don't think that's right. Let me exit down. Let me see if it works here. Yeah, there it is. Router EIGRP 100. And then we're going to do passive interface for loopback. So loopback 0, right? We make that a passive interface. And then we want to make a passive interface for fast Ethernet 1.1. All right, so enter the commands below. We did that. What changes do you expect to see in the routing table on R5? Well, I don't think router 5 is going to know about these networks behind R1 anymore, because R1 is going to stop telling it that information because it's a passive interface. So we need to look at R5's routing table and see if that's correct. So we'll hit enter and show IP route. Okay, so there, get that. Okay, D is EIGRP, yeah. S is static, D is EIGRP, and L is local. So C is connected. What was the question again? What changes do you expect to see in the routing table in R5? Well, I was thinking that it would stop feeding it information because it's passive. And EIGRP, yeah, so the EIGRP links are gone. The routes that EIGRP that router 1 knows about, it stopped sharing with router 5. And you don't see any, well, wait, those are that's to router 5. Oh, because router 5 is still going to know about them from this way. So that's why you see these EIGRPs listed. So 10.1.0.1.2.3, which are these. The 192.168, those are the loopbacks. I wonder if it just didn't update yet. 192.168, that's the loopbacks. 10.0.1.2.3. Oh, I see. Look. So, for example, the 10.0, do it this way. 10.0.0.0 network, which R5 would have known about from R1 if they had an EIGRP adjacency. It would have known it could have gone this way or this way. But now when you look at the table, you have 10.0.0.0, which is right here, which is the summary route of 10.0.3.1, which is over here. 10.0.3.1, that was our summary route, but the 10.0.0 is via 10.1.3.1, so it's showing it going that way. So I believe that that's the answer. You lose adjacency when we set them as passive interfaces and they stop communicating network information to each other. I think that's it. All right, verify the expected changes to the routing table in R5. We did that. And that ends this lab. I hope you enjoyed it and found it useful, and I will see you in the next video.